Yeah, physics problems. Okay. Yeah. All right. So this is part two in the video series on doing these problems, and I hope that you get so good at doing these problems that I never have to make another one of these videos again about how to solve these problems. So don't make me make another video. Learn this. All right. It's just kind of becoming torturesome. So we have a car traveling at 50 meters per second forward, and it comes to a stop in 9 seconds, and we want to get the acceleration. Ooh, acceleration is unknown, and the displacement, delta x. Oh, but we know that that's x minus x naught, and since they didn't tell us the starting point, we know that that's 0. Oh, exciting. Now, once again, we know that this is the initial velocity, and we know we have a time here. Look at all this great stuff. Oh, and look, it comes to a stop. Wow. So now we know that v is 0. Again, that little trick that you need to use from now until the end of your college career. So now, let's draw a picture, label everything in the picture. Ooh, picture. Let's draw a car. So there's a car. And then it's kind of going like that. Look at that. I've got it. It looks like it's moving. It's those little streaks. I'm a very good artist. Actually, that looks like I cut the heads off 2 turtles and then put it under another turtle. Anyway, we have the initial velocity is 15 meters per second, and it starts at a position of 0. And we know the time is 9. We don't know the acceleration. Okay, boo-hoo. And what ends up happening is we reach some final position, and we know that the final velocity is 0. All this great stuff. So now let's go ahead and set up equations. So whenever they want me to calculate acceleration, my one thought is, can I get away with using the first formula that they give me? So here's A. I want to see if I can get away with using this formula. Okay, so let's start and see if we can. So we have 0 equals A times 9 plus 15. And so when we do that, that ends up being acceleration is 5/3 meters per second squared. Or if you prefer, negative 5/3 meter per second squared. If you prefer, negative 1.67 meters per second squared. Either one's fine. Now let's do part B and see what we have here. So let's see if we can get these numbers. So we have x equals 1/2 at squared plus v naught t plus x naught. And so when we plug in our numbers, we have our unknown is x, and that equals 1/2 times negative 1.67 times 9 squared, which is 81, plus 15 times 9 plus 0. So we're going to go ahead and we're going to calculate that, and we'll get, assuming I did my math right, 67.4 meters. So this is the setup for sure. I just hope my arithmetic's right. So that's part B. Right. Well done. That's pretty much it for the problem. Now, if we had to plot this qualitatively, what we do is we'd go down here. So we have position, velocity, acceleration. And now we're going to want to have our graphs set up, so I'm just going to set them up like this, right here, and V like that. And A is also like this, so we would go ahead and we would set this up, and we would solve it. Just setting up the graph, we start off at rest, we go forward. And we don't stop it. We start off at velocity, and then our speed kind of levels off like this. And our velocity starts off fast and gets slow to 0. And our acceleration is a constant negative. So that's how that graph works out. Excellent. So that's it for that problem. Moving on to the next one. We have an airplane taking off with an acceleration of 2.5. Oh my goodness! So at this point, I almost want to get to a point where you're just kind of reading and sort of half reading and putting acceleration as A, and you say it travels 750 meters, so we'll put this as x final. X naught is going to be 0. We want to know its velocity at takeoff, so that's v. We're going to assume it starts from rest because they don't tell us the starting velocity. So we'll assume that v naught is 0. And once again, let's just draw our picture. So we'll have an airplane. Yay, beautiful airplane. Woo! So we're going to label our letters. So we have position, whoa, sorry, wrong color. We'll have our position, x naught is 0, v naught is 0. We don't know the time. And we know that we reach some endpoint right here where we take off into the wild blue yonder. And we have v final, we don't know. We don't know. We know that x final is 750, and we don't know the acceleration. Wow, this is just great. So let's go ahead and put some things into our calculations. We want to know its velocity of takeoff. So I'm going to give you one hint. We don't know the time. Why don't we try to see if we can use the equation that doesn't have time? So we have v squared equals v naught squared plus 2a times x minus x naught. So let's go ahead and plug in our numbers. So we don't know v squared, but we do know that it equals the initial velocity squared plus 2. We do have the acceleration. I misread. We're told 2.5 meters per second squared. Good for us. So I can put 2.5 in there. And then I have 750 minus 0. So when I go ahead and get that, I'm going to get v squared equals 5 times 750, and when I actually multiply that out and then get the square root, the answer that I will get will be 61.24 meters per second. And I'm actually going to let you guys figure out which one this is. So I think what we'll do for your quiz for Monday is we're going to do this question. And what I'm going to add to it is calculate how far it travels in that time, or in that part of the trip, or however you want to say it. I want to figure out how far it travels, going from 45 to 65 miles an hour, as well as the time. So that'll be your quiz, and it'll be really exciting and very dramatic, I'm sure. So get these problems learned, get these problems set up. I would recommend practicing all these other problems, which I don't even know if I have them here, but it looks like I don't. So yeah, there's more problems in your learning packet. We're going to do some more of those on Monday and Tuesday. So work hard.